This lesson is linear inequalities in two variables. We will graph linear inequalities on the coordinate plane. A linear inequality in two variables relates two variables using an inequality symbol, such as y greater than 2x minus 4. The graph is a region of the coordinate plane bounded by a line. This line is called the boundary line, and it divides the coordinate plane into two regions. So, for example, y equals 2x minus 4 would be that red boundary line. It divides the plane into two parts. One part where it's y is greater than 2x minus 4, and one part where y is less than 2x minus 4. If I were to graph y is greater than or equal to, this boundary line would be solid, and I would shade above. If I just had y is greater than 2x minus 4, the boundary line would be dashed because those values would no longer be included in the solution. So let's try one. First thing you do in graphing an inequality is graph the boundary line, which would be the y equals 1/2 x plus 1. Okay, so how do I graph that? I graph the y-intercept of 1. Rise over run is 1 over 2. 1, up 1, to the right 2, since it's positive. Up 1, to the right 2. Oops, hit it a little too hard. Come down 1, to the left 2. Okay, and after you plot your points, then you have to look and see what's my inequality. My inequality is just a less than. So that means this line must be dashed. There's no half equal sign, so the boundary line is not included in the solution. If you don't know which region to shade, then you have to test values. So you may want to test in the original equation. So here's my y less than 1/2 x plus 1. So I like to test anything not on the line, but 0, 0 is the easiest one to do. So I'm going to test 0, 0. 0 less than 1/2 times 0 plus 1. So 0 less than 1. That is true, so I would shade the region that includes the 0. Okay, let's go to the next one. Y is greater than or equal to 2. You want to graph y equals 2. What does y equals 2 look like? Well, y is always going to be 2. So there's y equals 2. So it doesn't matter what the x value is, it's going to be 2 for the y. Take notice that I have a greater than equal to, so it is a solid line. Solid line. Greater than, which region would be greater than? Greater than would be everything above. Okay, it's your turn, you try. Looking at that first one, you graph the line y equals 3x minus 2. It is a greater than equal to, so it is solid. Test a value. Again, you can test 0, 0 for this because it does not rest on the line. And testing that, it ends up being true, so you shade where the 0, 0 is. The second one is less than, y is less than -3. So you graph y equals -3. It's a dashed line, and less than is below. Okay, so that's graphing if you're in y equals mx plus b form. What if we are in standard form? We could test our graph using intercepts. So the first thing you want to do when we have, this is called standard form, when we have variables on one side, numbers on the other of your inequality. So the first thing you do is find the x-intercept, which is 1, y equals 0. So you have 2x greater than equal to 6. So x greater than, and actually it's just the equals part. So you would plot that, x equals 3. And then the y-intercept, which is when x equals 0. So y equals 2. You look to see your sign is greater than equal to, so it's solid. And then you test the region. Again, I can test 0, 0. Because that is not on the line. So 2 times 0 plus 3 times 0. Is that greater than or equal to 6? And that's false. So I need to shade the region away from that point. Now it's your turn. Okay, hopefully you found that your x-intercept was 4, your y-intercept was -3. Dashed line because it is only greater than, no equal to. You can test 0, 0 again. You find out that it's false. And you shade the region then away from 0, 0. And that is the first part.